Hello, this is Paul from Foresight Tech. In this lecture, we're going to introduce the binomial distribution and show you how to find the probability for this distribution. The major one, we are going to use the two formulas in the graph calculator. Okay, that's the major one. So first, what's a binomial distribution? You know what distribution is for a variable, right? So we're talking about the most important discrete variable, random variable. Okay, random variable. Binomial distribution is came from binomial experiment. The last topic we showed how to determine if an experiment is a binomial or not, right? Suppose now we have the binomial experiment. Okay, include the total number of trials. Okay, is n. The total number of trials is n. Okay, and each outcome, okay, the outcomes for each trial is only 2, remember? So in this case, and we define one of the outcome called the success. So the other outcome which is failure. If we keep in mind that the success we have to define. After we define this, so we have a probability, right? So probability of success, we call the probability of success P. And another is the probability of failure. So put it together is 100%. So Q, the value probability should be 1 minus P. And this single trial, usually in the history we call the Bernoulli trials. Okay. And another is independent IID. Do you remember? So this we call the binomial experiment. Because we already defined the success, now among the total n trials, how many times you get a success, we can determine. This is the random variable. Okay. After we have a binomial experiment, the number of the successes, okay, the total number of successes we define as the random variable. Look at them. Okay, this variable we definitely find that the distribution is very known distribution called the binomial distribution. So first, what is the possible value for x? Okay, the success time is either no success or 1 time success. The maximum is n time success, right? So we determine this first, and then the notation binomial. So look at this random variable can pick this value. So each value has a probability. This is a complicated probability. So the PDF, right, probability distribution function is here. And we were going to show you later, okay, so how to prove to get this formula. But first, the notation, what is n? Is how many times? And what is p? The probability of success. And what is x equals r? Okay, means the probability, this is the probability of r successes among n trials. And the probability you can see is among this. So the first number is a combination, right? So pick r from n. The second is p is to then the power q is then minus r's power. Everything we know. Okay, so the probability we know. I mean, you definitely get the distribution. This distribution we call the binomial distribution. The notation is this. And one more, I show a little bit. Do you remember any distribution if we add all the probability together? The sigma px equals what? Equals 1. Okay, so you can go into see. Okay, add all these together exactly equals 1. And this y equals 1 in the history is very famous. We call it binomial theory. Isaac Newton made the contribution to this result. Okay, this is a famous result. That's the definition. I have to show you the 2 easy examples how to determine, okay, binomial distribution. For example, Philippe coin 10 times. I'll give a coin here. Okay, I have a quarter, a coin. Philippe once, Philippe twice. Do you remember this? If we Philippe 10 times, this is a binomial experiment, right? We determined before. And if we define what is a success, if I get ahead, my purpose is to get ahead. If I get ahead like this, I get ahead, right? If I get ahead, I will be success. I succeed. If I did not, I fail, right? So we determine the success among all the 10 times. How many times I get a success? probability is 0, probability is 1, probability is 10, the maximum, right? So this the number of success is a binomial distribution, okay, definitely, because this success number came from binomial experiment, right? Okay, how do you about the notation? Is BMP, what is n? 10 times the total trials. What is P? This is 0.5. Why? Because I have a 50% to get the head, right? To be successful. This is the first example. The second, can we look at it? We roll die 50 times. I have a die here. I'm going to roll once, roll twice. We already know if I roll the 50 times, this is an experiment. It's a binomial experiment. Okay, and then if we define, if I get a 5, it's be success. If I get a 5, no, I fail. Probably, okay, so it's not easy. Okay, if I get this, means what? I get number 5, I succeed. What the chance to be succeed? And I have 1 out of 6, right? Among 50 tries, now we look at how many times of the total success. Successes is a binomial distribution. And the n is 50, the probability of success is 1 out of 6. What is the probability of failure? 1 out of 1 minus 1 out of 6, which is how many? Is 5 out of 6 to fail the game, right? Okay. And later I will have a lot of example. Okay, show you how to determine the x, the binomial distribution, and then how do you find the probability. So now let's look at it here. This is a kind of a proof. Okay, so and this is very theoretical. Okay, so we learned this from counting technique. Remember that. Probably counting technique is a little bit hard to use. So if someone you don't really like this, you can just skip this part. Okay. If someone you like the theory, so look at it. How do you prove? And if x is the success time among n trials, success probability is p. This means is a binomial distribution. We just define. Then what is the PDF? Okay, what is the probability of getting R success among n trials, right? So we just show you is this. And of course R is probably 0, 1, or goes to the maximum success n. How to prove this? Okay, we do a few steps. I will go much faster. Okay, so the first case, this case we can be success. What is success? Success to get R successes among n trials. Okay, if I draw the box here, is the first trial, the second trial, the rth trial, the R plus 1 trial, the nth trial. This is all the order, the trials. Okay, if I want to get the x, get R success, this case 1, the easiest. If the first R times, the first R trials, I all get the success. See how many? This is R successes. And then what left? M minus R. Each time I get a fail. What is the probability for this event to happen? As we look at it, because a lot of steps, that's the probability multiplication rule, right? For the probability case 1, how many? This probability get a success P times all the P's, right? R P's. And this is a fair Q, all the Q's. See how many P, R? How many Q, N minus R? See, we get this term is very similar with this term, right? It's exactly the same. But you think now, and the probability to get R success is not only one case. Okay, for example, probably I will be successful at the last R times. The first N minus times I will get a fail is also possible, right? Okay, there's another case. Or we have another. You just randomly range the position, the position of the R success among n trials. See, a lot of times, case 1, case 2, how many total cases? Okay, it's exactly the ways. If someone remember what the counting technique, so we learned. The total cases is the total ways to choose R. Okay, this is the position. Choose R from n trials. And there is the order does not matter, so it's a combination. Okay, combination, which means this. Do you remember the notation? This means n choose R combination. Or we say the choose R from n, right? You know how to find this value in the calculator, so there's no problem for us to do calculation later. And if we get the total number now, we can finish it. This is proof. If we want to be x equals r, right? This is x equals r. Means what? X success times means I want to exactly get the r successes. R successes, each success is case 1. The probability we already know. This is the probability of case 1. But we already say how many cases. The total number of cases is this number combination. So we put the combination the first time is okay, because each case had the same probability, this. And then repeat how many times. This is the total times. Everyone, can you compare this to the beginning? That's exactly the same. Okay, I hope you get something. This is how to prove the complicated formula. If we learn the counting technique, this is not a big problem, right? Now, the major one we are going to is find the probability. We have a PDF, right? So if we just have this. Do you remember this? We have a PDF, okay? It's the probability distribution function for the binomial distribution, but this is complicated. And I also have one example later to show you how to use this formula, okay? PDF formula later. But the major one, please keep in mind, is going to use a calculator. We have two functions and the calculator to use. Two functions. Okay, so let me see. The first is a binomial PDF. Okay, PDF, what is P is a probability. The second function is a binomial CDF. C is a cumulative. Cumulative, you know what does cumulative mean? Add all together, right? And where the position is distribution. Can you see the distribution? Okay, so before we go into the definition, I will show you where is the location, because later I have to use these two functions, okay? All the probability we can find by these two functions. Let me show you where is the binomial PDF and where is the binomial CDF. And if you have a calculator, you can take your calculator, go with me. Mine is 83, okay? 84 is no difference, okay? Can we see? Okay, now I turn on my calculator. So first find the distribution. Can you see the variable above the variable, the distribution? Okay, so we have to go to second variables. Okay, now and we need to move it down. Keep in mind, okay, so move down a lot. Okay, a lot of times. Have you seen? Go to the number 0 is binomial PDF probability, right? Go down once. Binomial CDF. This is a cumulative. Keep in mind that the position is going to distribution. Okay, so one more time. Okay, I jump out. So going to second variable. So this is all we need, the distribution, and then go down, go down, go down. See, 0 is a PDF. A is a binomial CDF. Okay, later I will go back to use these two formulas. Now, what does this formula mean? So I have to define, right? So now look at the definition. It's very important there because all the probability can be found by these two formula, okay, in the calculator. So what does this formula mean? You definitely need to know. The first step. So binomial PDF, okay, we have 1, 2, 3. Okay, we have 1, 2, 3 input variables. Okay, this variable of course is from the binomial distribution, right? Okay, this means what? It means the probability X success time equals R means R success. What does PDF mean? So now you see, PDF means for this binomial distribution NP among n trials, and you will get exactly R times success. Have you see? This means the probability of exact R, because it's equals, the success time equals R, means exact R successes. Okay, and you remember we have a PDF, right? Do you remember this? If someone remember, that's PDF exactly is this PDF. Okay. Do you know? The formula is PDF, alright? So you can imagine. What is N is the total trials, P is the probability of success, R is the exact R successes. Okay, that's the events, the probability. If we look at the graph, okay, I draw histogram, okay, or I draw bar graph. So all the possibility for this random variable is 0, 1, 2 success, the maximum times, right? If someone draw the graph, it looks like this, okay. how tall so is the probability or the relative frequency. Do you remember? Okay, and where is the binomial PDF? The binomial PDF NPR is here. Okay, what is this means how tall? Okay, is how tall is this bar is the probability of here to get exact R successes. Have you seen? Each bar is the exact probability. And if in the probability distribution, this means PR. PR means Px equals R. Okay, what's the probability exactly to be success R times among n trials? I mean, do you remember one single bar is a binomial PDF? Okay, what is binomial PDF for MP1? MP1 is this. Okay, how tall? See, this is MP1, this is MP2, this is MP0. Okay, add all together. Remember, is how many? 1, right? Add all the height together. Okay, add all the height together is 1 because all the probability equals 1. The second, when we do application, not always to find the exactly R success. Okay, for example, can you look at what this means? X success time is less than or equal to R, means at the most, right? At the most get R successes. How to find this probability? We have the formula binomial CDF for cumulative. Okay, what does it mean? If this is the distribution, and the cumulative means add all the height the bars to the left together. See, from 0 to 1 to 2 until R. See, X success less than or equal to R means either 0 times success, 1 times success, or 2 times. At the most goes to R times. Add all the probability together is the binomial CDF. Have you seen? This is the binomial CDF, cumulative. Okay, that's very important for these two because we all have is these two functions. PDF is a single or exact success or single bar. Binomial CDF is the cumulative, add all the bars to the left. But remember, include this. Why include this bar? Because it's less than or equal to. See, you can imagine if I say X is less than R times, this time, if the success time is less than R, it's not at the most R or different. So now we have different other types. Can we see? Now we have this. I give you other probabilities, the formula for other probabilities. Here I only show you 3 more types. Okay, there's other more types you need to determine by yourself. Okay, I did not show you. So the first, if you want to be success less than R, I mean less than what the probability get less than R successes. What does it mean? Means the success time X less than R. This time, this is easy, not difficult. Less than R means what? Less than R means less than or equal to R minus 1, right? See, if I say less than 5 times get success, your success is less than 5 times, means what? So you get 0 times less than 5, 1 time less than 5, goes to 4 times is less than 5. However, 5 times is not less than 5. Means what? So this probability can be calculated by change R to R minus 1, which means this is what? 0 plus until R minus 1 is the cumulative. Okay, binomial CDF for NP. NP is from the distribution. The total trials, the probability of success, N minus R minus 1. Keep in mind that if here no equal, this is minus 1. You know what that this mean. That's easy to determine. However, we have these 2 more. More than R success. More than. If you play 10 times, you want to calculate the success time is more than 5. More than 5 means what? 6. Good, more than 5. 7, 8, 9, 10, or more than 5. More than 5, right? So this is the probability how to calculate. And it's better, the formula looks complicated, but it's okay. If you look at this graph, it should be very easy to understand. Can we look at this graph? Remember, this is what? This is the distribution, right? I draw the probability. Okay, all the probability added together is 100%. Doesn't mean the distribution. And do you remember now what the question? The questions ask you the second, okay, this. More than R success. If here is R, success R probability. Here is more than R. See, the right is all more than R. So I highlighted in this red is the probability we need to calculate. X R greater than R. What's the complementary? Or you know what the opposite? Px more than R. The opposite means no more than R. No more than R means what? Less than or equal to R. Can you see? If we find the probability of the left, so we can find the probability of the right, because the total equals 1, right? Okay? The sum equals 1. So now the question was the left. This is R, keep in mind. And this is just a definition binomial CDF. Remember? Say this is R. If we find this, so what is the right side? So 1 minus binomial CDF. This is R. Have you seen? That's the formula. Okay. That means how to find the right side, use 1 minus the left side. Give you a basic idea. Now the same. If they ask you these questions, let's look at these questions. At least there are successes. At least, you know what does it mean? At least means greater than or equal to R, right? If it's R, at least 5 times is 5 or 6. Okay, all that means this include R. Okay. So keep in mind that this formula is different, because this formula, this calculate, this event is different from that event. So we should have different formula. What is the exact formula? Please look at this graph, the same graph. So this time I have to highlight the order where the red one is the exact probability to find X greater than or equal to R. So this arrow I have to include. It's different from this graph. Okay, a little bit different. Can you see all the right side is the probability we need to calculate. At least there are success. So what is the opposite? Opposite is at the most R minus 1 successes, right? At the most. And at the most is this word, less than or equal to R minus 1 is the binomial CDF NP R minus 1. Therefore, the probability of the right side is 1 minus this. So I hope you remember these two graphs, okay? Or you can draw yourself an easy graph to find the probability you need. I said there are more even or probability need to find. For example, if you play the game 100 times, I want to know if my success is between 20 to 30. So between, I did not show you formula, right? What do you need to do? Draw a graph for yourself. Between should be in the middle, okay? And in the middle means what? You still do subtraction, but you need to think about it a little. Okay, so I did not cover all the cases, but these cases you definitely need to know. Okay, the idea is to draw the graph to show yourself. Now I have 4 questions to show you. Okay, all the questions here. 4 questions. Show you step by step how to determine. Okay, if something is if some random variable is follow the binomial distribution or not, and then if it is, how to find the exact probability. So look at the first. Have no background because it is already random variable X follow binomial distribution. So what is this? You should remember the notation. This notation means so here is n equals 4, the total number of trials. What it is, this is the probability of success. That means you're going to play a game 4 times. Each time you have 1 out of 6 chance to be successful. And this I guess is a random variable. Tell you what is your total time of success. Your success should be probably be 0 times no success, 1 time success, 2 times success, 3 times. The maximum is 4 times, right? Remember that. But now it's asking you find the exact success. This equals means exactly 3 successes among 4. You know what that is mean if I put it here. So now these questions is to find success, exact success. Okay, you say exact 3 successes among what? Among 4 trials, right? And you see, Bernoulli trials, of course. You get it? So now you need to find the probability. Now here is the probability to get exactly the 3 successes among 4 trials. Remember, we have a PDF. The first we use PDF formula. I copy the formula. This is the formula. Do you remember? This is a PDF formula. We already proved this. Okay. Now I will going to do calculation use the formula. So in the formula, what is R? So here exactly 3 times, and you know N is 4, R you know is 1 over 6, P. Okay, no, not R. Sorry, R is 3, P is 1 over 6. What is Q? Q is the probability you fail, right? So I need to find what is Q. I put it here. Q is 1 minus P. P is the opposite of success value. Okay, I do calculation 1 minus out of 6. Of course, how get 5 out of 6? Remember this number we have to use. So now we plug into the formula. Okay, follow this formula. What the probability of that? I show you here the probability x equal 3. The probability you exactly get the 3 times success is okay. This combination N is 4. R is 3, right? You know how to find this in the calculator. What's P? P is 1 over 6, so it's better to do this. 1 out of 6 put to the power. R is 3. Okay, what is Q? Already found. So I put it here 5 out of 6. What is the power? N is 4 times minus 3 is 1. Why is 1? 3 success 1 value. This is the time of the times of you get a value exactly. Do calculation. I already get the answer. Okay. So you do calculations. So how many you get? 0.015. This is the probability among 4 trials you will exactly get 3 successes. Okay, it's amazing, right? If we have this formula, easy to get it. Of course, with a lot of calculation, we do not exactly need this. Keep in mind that I said this is the major. I highlighted this. That's the one I recommend you to do. Okay, use a calculator. First, which formula? If you remember, just I showed you exactly is PDF, right? Is 1 bar. Okay, among the histogram is only find the height for 1 bar. Okay, what is the formula? I'll show you the formula here. We have to use binomial PDF. You remember? Okay, MRP. Sorry, MPR. Okay, don't change the order, otherwise you get it wrong. This is the definition in the calculator. Where to get this formula? I just already showed you where to find it in the calculator is distribution. Okay, go to there to find it. And I was going to use this. But before I was going to use this was my questions. Let me write down. My question is here. Px equals 3. How do you find this? Now the formula is this. What does this mean? I have to. What does this mean? This means the probability x exactly equals R. Have you seen? Okay, if I highlighted this, the probability exactly equals that. Okay, now x equals 3. This is R equals 3, right? This is exactly 3 times success. That means exact. You have 3 successes. Of course, is among 4 trials, right? And these questions among 4 trials. So this is among 4 trials, and this is the success rate or the probability of success 1 out of 6. What is R? Success 3 times, and the plug into the formula should be what? Binomial PDF, and 4 1 out of 6 and 3. Okay, and then look at the calculator. So please, everyone, you remember this, and then I will going to show you the calculator how to get it. Okay, so here is the one. So my is Texas 83. So yours, if it's 84, is the similar. Okay, so the clear everything. Do you remember what our questions? Going to find the binomial PDF for 4 1 out of 6 3, right? Okay, now where I use the binomial, I already showed you distribution, second variable. You have to go down to 0, right? Go down, or you type 0, no problem. I find the PDF, okay, and then end. So you have to type exactly follow NPR. What is N? 4, comma. What is P? Is 1 out of 6. 1 out of 6. Okay, and then comma. So for 83, you have to do this comma. If yours is 84, you just date will just ask you what is N, the total trials, what is the probability of success, and what is your exact success times. Okay, so success times is 3, and then put a parenthesis. So this is everything NPR, and then end. How many? 0.015 if I round. Okay, 0.015. So I get the answer. I put the answer here. Now you see, what did we get? We just get a 0.015. Okay, it's not a stopper. Can you check this answer and the PDF formula? They are exactly the same, right? They are exactly the same. So this one and that one, they are exactly the same. So no problem. And in the future, we'll only use the calculator. Don't go to the PDF. But you know, all the calculator just follow the PDF formula. Another example, can you see? Okay, and look at this example. Now, this example, they did not show you what is X follow all kind of distribution. You have to make it for yourself. You have to make it for yourself. Now, how to make it? Please read the questions. To try to hit the shoot the bullseye means get a success. Okay, what is the rate? It's 46% of the time. 46% of the time, we simply say the success rate or the probability of success to hit the bullseye is 46%. Okay, means what? So you have to determine what is success. See, do you remember? Any X follow binomial distribution comes from binomial experiment. I mean the single probability trial. You need to know what is the success, what is not the success, right? That's the first step, everyone. If you want to build the distribution, you need to know what that distribution means. Success, define the success is the first step. What is success? Hit the ball, right? We can see hit the bull's eye. If I say this is a success, you can determine, okay, you can define success for yourself. Even it's different from mine, no problem. However, the problem will change, okay? The questions will change, keep in mind, okay? If we are going to determine this is success, what the success rate, probability, this one, right? This is the P among the binomial distribution. Success rate, the probability of success. Now see the question, she shoot 9 arrows, shoot 9. So each shoot is a probability trial. Success is hit the eye, and not a success value is not hit the eye, right? And the hit the eye has a probability 46%. So not hit if I wrote. This means exactly how many? It's a 0.46. And you know what is Q, right? So Q is 1 minus 0.46 is 0.54. What is the probability of value? We also know. I don't know. So later what the question they ask. Let me go into this probability trial. Now, how many probability trial? Shoot the 9 arrows. Trials 9 times, 9 trials. I mean now you get it. This is N, right? Okay, I say N equals 9. 9 probability trials. Okay, what's the probability that she gets? Can you see the questions? Now almost, what the question? Let's look at it. What the question she exactly gets for balloon's eyes means shoot, or you say is how many success from here? That the questions. That the questions she gets these questions. What the questions? What the probability she exactly for success, right? We say get exact for successes, and this is the question. Remember exact, how many times that's exactly from the first. Why here I put the assume the assumption? So because in this way, and we can get a Bernoulli trial. We can get a binomial experiment. Therefore, when we define, we can define the number of success. So that one should be what? Should be the binomial distribution. Now we have everything. All we need to do, you set up a success. This is a binomial trial. Trial 9 times, and you get exactly 4 success, because you know you define the success, right? If I shoot a little bit detail here, please, this is important. You have to define the success first. See, this is the first step. The first step is to define, what is a success. Keep in mind that this is the first step, very important. Okay, you cannot see. The first step, you have to define what is a success. Okay, define what is a success. We have defined the success. Therefore, the total number of success. So we can set up now. Now easy. I say X is the successes. The total successes is means hit the eye, hit the bull's eye. Among how many? Among 9, right? Among 9 arrows. Among 9 shoots. Okay, it shoot 9. So how many success? So you remember this. Success times among 9 Bernoulli trials is follow what? Binomial distribution. If I say now, we know. I should follow binomial distribution. Here is n. N is 9. Right? Remember, n is 9. And here's p. P is there. It's 0.46 success rate. Everyone, go to here. We get almost everything done. You set up the question. Now we look at our question here. The final question is what? Get exactly 4 successes. Means you find the probability X success time exactly equals 4. Okay, so did the questions. How do you find it? Do you remember we have a binomial PDF, right? If somehow you forget the formula, I put it here. In the calculator, we have this formula. X equals R success. R success is exactly equals binomial PDF in the calculator. Here is M and P and R, right? That's the formula. If I show you, this is the formula, okay? And I should summarize for you, right? Summarize that for you. And what is R? Exactly get 4 times, right? And what is M? See, N is here. It's 9. Okay. What is P? So you know this is N, right? This is P. So P is 0.46. What is R? R is 4. Now everything you have. All you need to do is easy. Just plug in. So plug into this formula is binomial PDF. And the N is 9. P is 0.46. R is 4. And remember, go into the distribution, okay, in your calculator. So you're going to find how many. I already find it is 0.295. Okay, what does this mean? And this means the chance. So how many? If you shoot, if the person shoot 9 times, what's the chance to exactly get a 4 shoot success? It's 25.9% chance. Okay, so here the first. Look at another example. Can you see? Now it's almost the same. Okay, no big difference. I will go much faster than the first example, the previous example. Can you see the question? Certain college, 33 of the physics major belongs to ethnic minority belongs to. If 10 students are selected at random, okay, which means what? From here, I think you understand what they ask you. See, what the probability that no more than 6 belongs to an ethnic minority? I mean, among these physics major, some students belong minority, ethnic minority, another does not belong, right? This is what? This is a Bernoulli trial. Okay, we can see because the questions ask you how many students belong to the ethnic minority. That's the success. We need to determine what is success. Have you seen? We take one student, okay, to check if the student belongs to the ethnic minority. We call it success. This is Bernoulli trial. Two outcomes. Define this is a success first, okay, and then we know the Bernoulli trial is what is the success rate. What is the probability of success is 0.33. Good. Then look at the questions. We're going to 10 trials, right? 10 Bernoulli trials means to ask 10 students, to check 10 students. So from here we get n equals 10. Is that right? Bernoulli trial 10 times. And the questions, no more. Let me look at no more than 6 belongs to. These are the questions. Means you get how many success. No more than this time is not exact success. Is no more than, or we put the words, no more than 6 successes. Of course, is among how many trials? Among 10 students, or you say among 10 trials or 10 students. No more than means what? No more than means less than or equal to. No more than. So means, if you remember at the beginning how to set up, if set up X is the total success. So these questions ask you X is less than or equal to 6, right? Okay, almost now. These are the questions. You see, this is the question. Now set up. You already set up the success, so now we can determine set up X is the success, right? Success is times. This means the times of success among 10 trials, or you say is 10 students, no problem. What does this mean? Means that you're going to look at the 10 students one by one. How many students belongs to the ethnic minority? Okay, this is a random variable. So what? The same X follow binomial distribution. Now definitely, n is 10. P is here 0.33. See, and you know this is n. This is P. You set up almost. Now we can set up the questions. What's the question? The question is the probability, the success time, which means X, less than, no more than 6. Okay. Do you remember we have this formula, right? So how to get it? Binomcdf. If someone you forget it, I shoot the formula here. The X, this means at the most, right? At the most, or no more than. At the most, this is R. The formula is this is binomial C cumulative, right? CDF and the MPR. Okay, do you remember this formula? So I will get. I just show you the formula. You don't need to exactly. This is the formula we need to follow. And this is no more than or at the most. That's why we use CDF, right? Okay, among our questions, R is 6. And we know N is 10. We know P is 0.33. Now R from the question is 6. Everything is there. All we need to do is use the binomial CDF. Okay, N10, 0.33, and 6. I showed you how to do, right? So you're going to do the calculate the distribution, find the binomial CDF, plug into these 3 input variable, and do the calculation. I already got it is 981. 98% around means what? It's a big chance, right? Big chance. One more questions. Expectations. The last question. It's almost the similar now. This question, a test contains 10 true or false questions. Okay, to pass the test, students must answer at least the 6 questions correctly. If students guess, randomly guess, okay, 2 choice, 0.5, 50% to get it correct, 50% to get it wrong. What's the probability that the students will pass? So keep in mind that. So we need to link these questions to binomial distribution, which means what? We need to link the questions to success times. See, pass the test means answer 6 question correctly. Means 6 successes, which successes. So each success you need to determine this is the success. Easy, right? I mean, answer the question correct, we got a success. So now, Bernoulli trial we have. Answer correct, you get a success. What's the chance? See, guess. This means what? This is already tell you the success rate or the probability to get a success is 0.5. Okay, so keep in mind that you know this classical model. And then how many Bernoulli trials? N. All we need is here, right? N equals 10. Good. Now almost. What the questions? Pass the test is the questions. If I change this, pass the test means answer at least 6. Okay, which means at least 6 what? Answer success means success. Okay, and now you know the probability to find what at least 6 success, or I showed a little bit more, among how many trials? Among 10 questions. Okay, 10 questions or 10 Bernoulli trials. So you know how to find this, right? Now set up. So now what do we need to do? We set up X is the success is the total number of success among 10 questions. Okay, or I say 10 guesses, right? You guess each questions. And then now this exactly X follow binomial distribution. The total number of success. N is 10. P is 0.5. Okay, I'll show you a little bit that this is N, this is P. Okay, M and the P. Now I will directly go to the questions. The question is the probability at least 6 success, which means X at least. At least means what? Greater than or equal to. So keep in mind here at least is this greater than or equal to, right? How you see? We have to use this greater than or equal to 6. Okay, do you remember we have a formula, right? This is from the other probability I showed you. If you go back to check, and is this at least the X greater than or equal to R is the probability. If you go to the formula, what do you find? This is going to find the probability on the right side, and you should use 1 minus the probability. If somehow you understand that, you don't need to exactly memorize, okay? Or you going to check, you know what does it mean. This is NP, what is the number here? So the right is start from R, so the left is stop at R minus 1. So here what do you need to do? R minus 1. If you remember the graph. So here the formula. All you need is this formula now. This is not important because we have the formula, right? What is important? Important is set up, okay? Set up the X. Get the distribution, and then use the formula. Not difficult. What is R? R is 6, right? So what's N? N is 10. What's P? Is 0.5. What's R minus 1? R minus 1 equals 6 minus 1 equals 5. Be sure, okay, to take care. R minus 1 is 5. If you put a 6, you will get a wrong answer. Now I plug into the formula. Binomial CDF 10.55. Okay, you know 1 minus this, everyone you know to calculation. Going to find CDF, we find the answer 1 minus that answer is how many already get? Is around 0.377. I mean 37.7% of the chance. Okay, thank you. That's all. Thank you.